Hello students, one of the important topic of complex integration is Cauchy's residue theorem. To study Cauchy's residue theorem, we need to know the singularities. What is singularities? The point at which the function is not analytic, ceases to be analytic. There are three types of singular points: removable singularities, poles, essential singularity. These are all the types of isolated singular points. Next, we are going to see how to find the residue. If it is a simple pole, the residue's limit z tends to a, z minus a, f of z. If it is a pole of order m, then the residue is 1 by m minus 1 factorial, limit z tends to a, derivative with respect to z, m minus 1 times z minus a, the whole power m into f of z. If it is a rational function, residue is g of a by h dash of a, provided f of z is g of z by h of z. This is applicable only for simple poles. Cauchy residue theorem statement says that the function f of z is analytic, integration over c, analytic inside and on a simple closed curve c. Then integration over c f of z dz can be found by using 2 pi a into sum of residues. Sum of residues of isolated singular point which lie inside the contour C. So take this example. We need to evaluate integration over C, 1 by z dz. The contour given here is, there is curve given here is mod z equal to 1. Center at the origin, radius 1. Put the denominator equal to 0, you will get the singular point. Singular point is z equal to 0. Z equal to 0 is repeated only one time, so it is a simple pole of function f of z is equal to 1 by z. So this z equal to 0 lies entirely inside the curve given mod z equal to 1. So we need to find the residue for this. Formula for residue is limit z tends to 0, z into f of z. F of z is 1 by z. So altogether residue is 1. So substitute this residue in Cauchy residue theorem formula. So it is integration over c 1 by z dz equal to 2 pi I into sum of residue. So here the residue is 1, so altogether the solution is 2 pi I. Pole of order m. So this example is an example for applying Cauchy residue theorem where the singular point is repeated more than one times. So see this, we need to evaluate this. Put the denominator equal to 0, we will get z equal to 1. That z equal to 1 is repeated 3 times, so it is a pole of order 3, otherwise called as triple pole. So we need to find what is the residue for triple pole. So the formula for residue of triple pole is 1 by 2 factorial. Triple pole means n is equal to 2, n plus 3 equal to 1. So limit z tends to 1, double derivative with respect to z into the function f of z, which is e power z. Equal to, if you differentiate this twice and take limit z tends to 1, you will get the value as e by 2. So substitute that e by 2 in Cauchy residue theorem, you will get the answer as 2 pi I into e by 2, which is equal to pi I by e. So here this point z is equal to 1 lies inside the contour.